Hey, welcome. So this is a continuation of the first video, and due to technical, there is not just technical difficulties. I'm out of time, so I cannot really type everything out and talk about it. So this is just an improvisation. So bear with me, please. So basically, we've already discussed about the difference between an information system and a computer application. So, an information system is a set of related components. We've already talked about it in the first video. Now, let's look at some principles of Agile. So, the Agile Manifesto. The Agile Manifesto was written by 17 leaders, just to make sure that the Agile follows a certain set of principles, and then there are 12 in total. So we just look at them. The ones in the brackets are some sort of keywords to help you remember them very fast in case you forget the entire phrase. So you get it. Yeah. So the first thing is early value delivery. I'm going to wrap through this video. I want to hurry up and finish it so that I also start preparing myself. So there's early value delivery, and then there's change for good. All the changes you have to do in an agile development has to be changed for good. With agile development, you are building something. You are building it in such a way that it can adapt to the environment. You can add and remove more things, and then you do that by using iterations and increments. Iterations is when you work after a short while, you go and show it to your supervisor or your manager or whatever, and then increment is working in small chunks. So we do this so that we can be able to add and remove things from our information system. And this method is the agile development methodology. Now the principles that come with this method is the 12 principles we are looking at right now, which happens to be early delivery, changing for good, and then weeks, not months. So it should take you weeks, not months, to bring out something, a new system. I mean, to bring out an update or something. Yes, exactly. So the next thing is business people and developers. Partner with business. Be speaking more with the business people, and then the team building it should also be motivated and trusted. Motivate and trust them to get your job done for you, and then direct and open communication. If there's a chance for you to meet the development team and talk to them face to face, just do it instead of talking to them over phones, because that one has more. It comes with a more seriousness and things. And then the seventh principle is show and tell. You get it? You show me, then you tell me. Don't tell me. Show me and tell me. Because I am from a show working. You show that to me and then you come and tell me about it. That's the seventh principle. And keep it steady. Once it's going forward, you are going forward. Don't do something that will make you, start going back. And then the ninth principle is never compromise quality. Agile development is always about quality. Never compromise quality. Once you compromise quality, you are going out of agile development. The 11th architecture is empower the team. The 10th architecture is simplicity. Always make the user do less. The amount of work that the user has to do should be very, very small. You see, or the person using the system, the amount of work the person has to do should be very, very small. So you should focus on keeping most of the work, getting most of the work done for the person. So keep it simple. And then 11th principle, empower the team. Once they are empowered, once they are motivated, Charlie, they can think and get things done. And then the last principle is continuous improvement. Never stop improving. Always try to bring an upgrade in weeks and not months, as said in the other principle. Now let's look at some. These are the basics of Agile. As I said earlier, the 12 principles written by the 17 leaders to how Agile should look like. Now let's look at what system development methodology is. Now the system development methodology, it includes instructions for completing each core process by using the specific models, tools and techniques. The core process is what we looked at in the first video, which is understand the need, capture the vision, capture the vision, define the solution, communicate the vision and the solution. Those ones, that's the 6 core processes that they are talking about in this case. So a system development methodology, it just It is just instructions that will help you complete those core processes using some specific models, tools, and techniques. We'll talk about the models, tools, and techniques later. Now, system development methodology is also the same as development process. They are not different. It's the same. When they say development process, it's the same as system development methodology. Now, when it comes to agile, I'm going very fast. Bear with me. I don't want to make the video long. Some specific agile development methodologies are unified process. You see, as I said, the agile is not like a specific development methodology. It's a type of methodology where a lot of methodologies can be grouped under. So it's like you can categorize a lot of methodologies under the agile methodologies. That's why it has its principles. So if a methodology should fall under the agile methodology, you should follow all the agile manifesto. That's the principles on that manifesto. So here are some of the methodologies that fall under the agile methodology. We have the agile unified process. We have the extreme programming and Scrum. Scrum is the most famous development methodology in this case. Now moving on. Okay, what do we have here? We've already spoke about what a project is. A project is a plan undertaking that has a beginning and an end and produces and produces a well-defined product or results. So yeah, there's nothing more to talk about this. The information system development project. It is a plan that produces a new information system. So you see, we know that a project is a plan, it's an undertaking plan that produces a result. And they are asking, what is information system development project? So it is a plan undertaking. So instead of producing results, it produces an information system. You know the exact information system the exact result you are supposed to produce, which is an information system. That's all you are supposed to do. Now, system development life cycle. What is it? Now, that's the SDLC. The system development life cycle is a framework that involves all the activities required to research, build, deploy, and often maintain an information system. So you have a system development methodology, a framework. Okay, it tells you, okay, you have to do this. If you do this, do this, do this. After that, do this. After that, do this. After that. So when you follow everything and do everything, that's the system method, the life cycle, the development life cycle is telling you to do. At the end, you'll be able to get your system up and running, and then you also be maintaining your system. So it's just a set of activities. It involves all the activities required to research. You have to research before you build. After you build, you deploy. And after you deploy, you have to maintain. So keep it in order. Don't mix it up. So it includes all the set of activities required to research, build, deploy, and often maintain an information system. Now there are categories. You have the predictive approach and then the adaptive approach. Predictive approach, in this case, let's use waterfall model. So the predictive approach is a traditional method we spoke about in the first video, which is the waterfall model. And then the adaptive approach is the agile, because you can change it and make it adapt to new systems. You get it? So the requirements for the predictive approach is that you have to understand the system well, and then the system should be understood well, and then should be also defined. As I said earlier, if you want to build a system using the waterfall model or using the traditional system development model, you have to understand the problem it's going to solve. You have to understand how you are going to do it, and once you do it, there's no going back. So you have to understand the problem very well. So requirements are well understood and well defined. The word is defined and not designed, pardon me. And then there's low technical risk. You know what you are doing, so you are going for it. And then the rate of succeeding this one is, I think, 29%, and then the rate of, I think it's 14%, and the rate of not succeeding is 29% also. I don't really remember the values. And the next thing is the adaptive approach. With the adaptive approach, you don't really know how the requirements, you don't know what exactly you are going to do. You know what you are going to do, but you don't know exactly. You see, so you just give it around that area so that you can be able to change it. And then this one, there's higher technical risk. Sometimes you do something, it is not related to the thing. Google like this, they use the agile system methodology, because sometimes they bring updates and no one recognizes them. It's a technical risk. They will add something to Google and then you never know that something has been added to Google. It's a serious technical risk. Okay, so now let's talk about the predictive approach. With a predictive approach, it assumes the project can be planned in advance and that the new information system can be developed according to the plan. So it assumes that okay, you can plan the project, plan it once, and then build it. Build it according to the plan. Don't go anywhere. Just build it according to the plan. It's very, very simple as that. Now, the next thing we are going to talk about is the adaptive approach. The adaptive approach assumes that the project must be, more flexible. It has to be flexible, and then it has to adapt to change. It has to adapt to change. Once there's something you want to change, once there's something you want to add, you should be able to add it. That's concerning the adaptive approach. So the adaptive approach is agile, and then the predictive approach is a traditional, system development methodologies, which in this case is the waterfall, and those are the ones. Now, the traditional predictive approaches to system development life cycle includes, you have to initiate the project. How do you initiate projects? You initiate projects by, identify the problem, and then you seek for approval. You don't just identify the problem and then start to do it. No, you have to seek for approval and then start developing the new system. And then you go to the next thing. The next thing is project planning. Now you plan, organize, and schedule the projects. Then you move to the next thing, analysis. Discover, understand. Analysis is what should it do? Discover and understand the need. And then what must you develop to help the business? Then you design it. You come and explain into details. You configure, you structure the new components, the features, the functionalities of the system you are building. Then implementation. Now you program the thing, you implement it. Well, the design analysis you do, you bring it into like code, or however you are doing your system, you are working on your system, you bring it into like that way. And then you test the system. You make sure that the system is really providing the aid for the solution you hoped it will do. Like the thing you expected it to do, you just make sure that it is doing that thing. And then you go to deployment. So after you've done everything, you've tested everything is working, it's solving the problem just as you hoped. Then you deploy it, you install it and put it into the system for it to be used, so that it can be used for work and solve problems in the production world. You produce, like, you get it, just put it out there. So these are the 6 activities which are sometimes referred to as the phases. So like these are like the phases of the system development process. It is not that difficult. Project initiation, you initialize the project, seek for permission, and then you start working on it. Seek for approval to start developing it. Then you plan the project, you analyze the project, you design it, you implement it, you deploy. You get it. But there are sometimes they tell you to like talk about the support phase, like include the support phase of the system development process. So that one you will add the support. You get it, as I've written over here. So it includes, I couldn't take a full picture, so pardon me for that too. It includes activities needed to upgrade and maintain. This is talking about the support. The support phase, all it does is just to upgrade and maintain the information system after it has been deployed. The after it has been deployed is very important. Please not leave it out. So all what you have to do, how was the support phase does is after the system has been deployed, it will just this phase includes upgrading the system and maintaining the information system after it has been deployed. So you just be upgrading and maintaining. That is after it has been deployed. Yes, it just like Facebook. You see, Facebook has already been done its thing, but sometimes you go there, they've added new features. So that one is like this, that thing that adds a new feature and things. Is a support phase. But in this case, Facebook is a computer application. Please don't get it twisted. Now, what is the waterfall model? I don't know why I brought this here. It should have been in the first video. Now, the waterfall model is a system development life cycle approach that assumes phases can be completed sequentially with no overlap. Sequentially with no overlap. Sequentially with no overlap. So, once you complete a system, you move to the next system. You move to the next system. There's no overlap. Once you pass, you have passed. You cannot say, okay, I'll come back, or you cannot work between. You say, once you pass, you have passed. So it's sequentially. Sequence is like one after the other. You go next step. So sequentially, no overlap. Now, okay, what is the development? The new adaptive approaches to system development life cycle. So there's incremental development and working skeleton. If you quite remember, he gave us an assignment. He was like, we should find a iterative system development methodologies. So this is it. This is it. When I found it, I was also surprised. Like, so this is what he was talking about. So the answer is incremental development and the working skeleton. So we'll talk about the working skeleton very soon. But let's talk about the incremental development. The incremental development is an approach that completes portions of the system in small increments, small chunks. You get it? So incremental development, you do it small, small, kakra, kakra, small chunks. You take this one, then you do it. You take this aspect and you do it. You take this aspect and you do it. That's the incremental development. Now let's talk about the. Let's talk about the. Let's talk about. let's talk. Sorry. Let's talk about the skeleton approach. So with a working skeleton, a development system, the development approach. Oh, with a working skeleton, a development approach is what? What? A development approach. The working skeleton is a development approach in which a complete system structure is built, but with bare bone functionalities. With bare bones functionality. So you build a complete thing, but like it just solves the problem. Like bam, just solves the problem. Nothing else. Solve the problem. Just go ahead and solve it. You don't add anything. You don't add anything to that. There's this thing where the user sometimes the users, if they want you to add something to the system, the information system, they write it on a card. They are supposed to follow certain requirements and things, and then they write it and you bring it. If they have everything they are supposed to do and it makes sense, you have to implement it into the system. But with the working skeleton, it's just a bare bone structure. It doesn't include all these things. It's not thinking about the user, like you being comfortable with the system. It just works on the system. The system is supposed to solve this problem. It is solving it. So you see. So when they go like that, and then they will keep on adding functionalities and things as time goes on, which is the support phase. That is the upgrading and the maintaining of the system after it has been deployed. Yeah. So it's very, very simple. Now let's talk about a model. What exactly is a model? So a model is a representation of an important aspect of the real world. I know I'm going fast, but please bear with me. A model is a representation of an important aspect of the real world. Just simple. You take an important aspect of the real world, and if you take an important aspect of the real world, it's called a model. So models used in system development include representations of inputs, outputs, processes, data, objects, iterations, locations, networks, and if you are building, if you know how to like program in certain programming languages, or if you are into web development and things, you see that once you are creating a user, you have to create a user model. So what should the user give? His name, his first name, email, password. So that is like an input, what you're expecting the user to input, the things you are going to use with the user. If you are providing product information about a product, that's the output. So the things you want the user to see, you get it. There are objects which can include selections made by the user and things. There are locations and networks and things. And then there's graphical model, and they are just drawn representations that employ agreed upon symbols. People have come together to agree upon symbols and conventions, and the symbols and conventions that they have agreed upon, they are used to represent models, and then these models are referred to as graphical models. So moving on, what is a tool? A tool is a software that assists developers in creating models or other components required for a project. An example is a project management software such as Microsoft Projects. So anything that helps developers or assists developers in creating models or components is a tool. You get it? Now, what is integrated development environments? IDEs, Visual Studio Code, Sublime Editor, what do you call it? IntelliJ, all those things, they are all ideas. So they are a set of tools. You see, as I said, a tool is a software application that assists developers in creating. The IDs help developers to write the code they create. So you see, it's a tool. They are saying it's a set of tools that work together to provide a comprehensive deployment and programming environment for software developers. You have a programming environment where you can debug, you can refactor your code and all that. All right, so moving on, we're almost done, and I'm excited. I'm almost done. All right, so visual modeling tools, what are they? They are tools that help analysis, create, and verify graphical models, and also may also generate, program code. Sometimes you do the graphic. There's this thing. Those are into web development. Sometimes did I say web development? Pardon me, mobile development. There are some tools where like you drag and drop, you create your design and things, and then sometimes you can get the code for it. Node-RED. Oh, I should say what? Hello, you are disturbing me. Now let's go on. What is a technique? A technique is a collection of guidelines that help an analyst complete a task. So yeah, a technique is just a collection of technique. I use this technique to accomplish this. So technique like guidelines. I followed this to do this. So they are just guidelines that help an analyst complete a task. So some models of system components, use case diagrams. You probably know of them, flowchart and those things. And some models used to manage the development processes are iteration plan, what's it? Gantt chart. I think the N is supposed to be double. I don't remember. And stakeholders list and things. Yeah, so these things I don't think they're really important. Yeah, these ones are not really important. This one is just about Scrum. When it comes to agile development, as I said, there's agile unified process, there's extreme programming, there's Scrum. Extreme programming is just it has to do with extreme, you focusing more on the quality of the product. And then Scrum has got to do with like transparency, inspection, and then adaptation. These are the core principles of Scrum development. Characteristics of the agile characteristics of agile teams. They are small teams that work on a project using the agile development are called agile teams. Now their characteristics are small, usually less than 10. And then there's cross-functional. They have someone who does API. There's a designer in it. There's every needed person in each team. So it's cross-functional. It's not that there's group of analysts, there's group of designers, there's all those who creates APIs. No. In every team, you can find every one of them. And then they are self-organizing. They work on their own thing together. They figure out their problem. With the help of this, if they have a master, that is if they are using Scrum, they'll go to the Scrum master if there's any technical difficulties. Or if they are facing problems which the developers, it's not really like technical problems, like just problems regarding the methodology. They go to the Scrum Master. So roles in the Scrum is Scrum Master, product owner, developer teams or development teams. Yeah. So sprints are used in iterations. So they are a time box of like 1 to 4 weeks. So within 1 to 4 weeks, we want to do this, we want to complete this, and then deploy it. You see, iterations, you follow all the syscall processes in one iteration. So in one iteration, you do all the syscall processes and things. Yeah. That's all. So that brings us to the end of this video. I'm exhausted. Unfortunately, I couldn't answer some questions, but if you really understood all it we just did, you don't really have any problem at all. You're good to go. Just go through over and over again. Make sure you understand the concepts and you're good to go. Yeah. Alright, so stay blessed and good luck in your endeavor. Alright, bye bye. Please subscribe and like if you are new. That's the only way you can motivate me to keep doing videos like this.